Welcome to the third lesson, and in the third lesson we're going to look at control structures. So I will create a class for that. Right click on the package, select new, then Java class. We're going to call this control structures. Control structures comprise the looping statements and the decision making statements. So that's what we're going to look at. We will start with the decision making statements. We add main function to this class. Okay, let me check whether my environment is okay. Yes, it's fine, it's suggesting. Right. So we're going to look at decision and looping because the two form what we call control structures, and we're going to start with decision making. Decision making, we start with if statement. So if allows us to execute some statements based on some condition. For example, if we have a program that taxes based on someone's income only. If they don't fit in that criteria, they are not taxed, else they are taxed. So let's assume we will just, so that we are brief, we will declare here and not receive from the user 90,000. And then the rule is we only tax people whose salary is above 50,000. So we'll say if salary is above 50,000, then we will need to tax this person. So let's declare another variable here, double tax. We can leave it at 0 so that if we don't tax that person, then the value 0 will persist. So tax will be given by, if you're earning above 50,000, we can assume you're paying 20,000 as your tax. So multiplied by salary, divide this by 100, and this is the tax. This is now the tax. So notice, if someone's salary is below or just 50,000, then we don't tax. We only tax if that exceeds, if the salary exceeds 50,000. Let's declare another variable here, double net pay. Net pay. Here we could compute net pay as salary minus tax. So look at that. So this statement is only executed if this statement turns out to be true, depending on the salary here, which can be received at runtime. So this will sometimes be executed and other times not executed, depending on the value of salary. Right, outside here we can print the value of the net pay. I want to be as brief as I can. So this is net pay. Let's run this program. Now that this salary is 90,000, it should be taxed at 20%, and we should see that reflected. Okay. It's almost there. There you go. So it's been taxed. And you can see what happens if we change this to 40,000. Now it doesn't this condition is not true, it is false, and therefore this will not be executed. Therefore tax will remain to be 2%, 0, and then at the end of the day it will just print 40,000. So let's look at that. There you go. That amount is not taxed. Now, the next type of decision-making statement is if-else. If-else. So let's look at that. If-else gives us a block of statement that is to be executed if the condition is true. At the same time, a block of statement that is to be executed if the condition is not true. So I will modify this program slightly and say, we don't just want to tax people whose salary is above 50,000. If yours is below 50,000, we will also tax you at maybe 10%. So now, here, we will have another taxation statement, but we will now change the percentage here to 10. So what is this? If your salary is above 50,000, you pay a tax of 20. Else, what does else mean? If it is below or exactly at 50,000, then you will pay a tax of 10%. This statement is always executed regardless of whether we execute this or this. So let's run it as is and see what will happen. As it compiles, you can be thinking through this. Now, salary is 40,000. So what will happen? This part is false. So this will not be executed. This will be executed, and therefore we should be seeing 36. If else. If else. The other format of the other statement that is used for decision making is also a form of if, and we will call it, sometimes we call it else if ladder, or you can also refer to it as chained if else, where you have very many conditions and you want all of them executed. So for example, if we were to expand this further, we want to to tax you at 20% if your salary is above 50,000. If it is below that, then we charge at 10%. We could add another condition inside here. So let's come up with that. If it is exactly, so this is above 50,000, so we can have between 20 and 50,000, we can put that at 15%. So now here we will have to have another if. We will start with the else. Else if, then provide the condition here. Else if, then provide the condition here. So salary. So now the new condition we want to add is for people who are between 20 and 50. So look at what we're going to do. If salary is greater than 20,000, okay, and salary is let me just use 50,000 here, and I will change this to or. Or we looked at logical operators, so this should make sense. So if you are earning less than 20,000 or you are earning exactly 50,000, then this is what you'll be taxed at, and I will put 15% here. So this is 15. So you see, we now have a ladder. The computer will first check if you're here. If you're here, it will tax you at this. Else, it will move to the next one, check the condition. If you belong here, it will tax you at this. If you don't belong in any of this, then it will move you to the last category. Notice the last category does not have a condition, because it means anyone who did not fall into this, or if the condition was not matched at this point, then it must be matched at this point. In between here, you can nest so many others. You can keep chaining it here. Chain. A lot of the if statements can be chained here. So now I'll just run this and we'll see what happens. Currently it's 40,000. So what will happen? Salary is greater than 20,000. It's not greater than 50,000, right? So it will move here. It's greater than 20,000, yes. So it actually falls in here, but let's see whether that is what will happen. Right, it's giving us 34. Let's see whether 15% of 40,000 is giving us that. So 15 divided by 100 multiplied by 40,000. Yes, minus 40,000 gives us 34. So you can see it actually falls into this particular place. You can chain so many. Else if statements. Remember, this else is matching with this if. This if here has to match with an else statement here, which does not have an if and does not have a condition. You will need to remember that. Right, the next one is a slightly different statement, and we call it switch. Let's see how that works. It's also a decision-making statement. So there's no relationship between that and what I'm going to do here. But let's write the syntax. So switch is a keyword. Inside here, you will put an expression that reduces to either, it must reduce to, whatever you put here must reduce to either a number, let me just write an integer, or a character. Whatever you put here must reduce to an integer or a character. So you cannot use switch with decimal numbers here. So let me declare a variable here, int choice, right, and ask the user to enter any number between 16, let me show you. Enter number between 1 to 5. Enter a number between 1 to 5. Let's declare the scanner class so that we can have these values supplied at runtime. No, let's make it a bit more easier. So I will just initialize choice here. Choice is 4. This is just for making it very simple for us to understand. Then we will pass that choice here to the switch statement. So look at how this works then. So the switch has a number of cases. So we're going to come up with cases that match this possibility. The user could enter 1, 2, 3, 4, or 5. So we'll start with case 1. What should you do if the user enters 1? Because whatever the user enters, or whatever the value of choice, it will be passed to switch. Then switch will compare it with all the cases and execute the statements that are next to that case. So I will, I just want to print some random fruits depending on the number that the user enters. So if the user enters 1, I'll type banana. I will display banana. Okay. Then we need to remember after each case we must break so that we get outside of that case and we get outside of the switch statement. Remember, this particular place where we have this statement that outputs banana, we can have a lot of code, a lot of functionality. Right, I'll copy this so that I move fast. So another case, now this is case 2, possibility 2, mango. The user could also enter 3, so let's take care of that. 3. That could be apple. The user could also enter 4. So let's take care of that particular statement or possibility. What other fruit? Let's write watermelon. Yeah, could write watermelon. Okay, then the last possibility that the user can enter is 5. 5, and we could write another fruit here. Passion fruit. So look at that. But we don't leave at that point, because it's also possible that the user keys any other value other than between 1 and 5. They could key in any other value. So we also come up with what we refer to as a default case, which is executed when there is no value that matches what the cases that we have provided. So I will just write here invalid input. You need to make sure you use messages that the user can relate to. So what will happen? User enters a number, the number is stored into choice, then it is passed to the function switch and it is checked against this. Is the value that is inside choice equivalent to 1? No. 4? No. 2? No. 3? No. 4? Yes. We print this and we get outside the switch statement. In case the user supplies anything that is not here, then we will have default. Let's start with 4 here. It's running. Yeah, so it goes to 4 and prints melon. We could try a number that is not here. Supposing the user entered 10, what would happen? Let's start with that. 10. Oh, if that is the input that the user entered, 10, we want to know what would happen. So let's run it again with the value of 10. Invalid input because there is no case that matches the value that the user supplied. We need to remember that. Let me do something to underscore the importance of break statement. So now we put choice at 1, then do away with this break statement. I'll just comment on it and then see what happens. Whereas the output should be banana, let's look at what would happen if we remove the break statement. Right now, it goes to the next case and also executes it until it gets a break statement. If you remove this break, it will also execute case 3. And that would also mean if we have two cases that share the same code, for example, I could write here case 6, for example. Case 6 and case 1 have the same piece of code. So what I will need to do is not use any break statement in between here. And when you enter 1 or 6, the code will be the same. So it's important to use break statement at the end of the last statement within each case. So these are the very common decision-making statements that will be used in Java. I now want us to look at looping statements. Whereas decision-making statements keep some portion of the code, execute another portion of the code depending on some conditions, looping repeats a group of statements depending on some condition. So for looping, we have a number of statements, and the most common is for statement. So let's look at how this is used. Supposing I want to print a name like 2 times. Print a name like 2 times. So I'll start with the for loop. Always and close that. Then what is the starting point? So int I, that's just a variable that stores the starting point. Then when should we stop? We will keep doing this work as long as I is less than 5. Okay, then I++, we looked at increment operators in a previous lesson. You can refer to that. So look at what this means then. It means we want to do this work that will be put here, starting from the moment I is 0, and as long as I is not greater than 5, and every time we do it once, we need to add 1 to the value of I, so that we never find ourselves into a never terminating loop. So let me just print a statement here. Statement here. Just print hello world, or just hello. Okay, so let's see what will happen when we run this program. You can ignore the code from the previous the subject or topic that we looked at. We focus only on the for loop. So let's run it. The output is here. So look at that. Hello, 1, 2, 3, 4, 5. So this statement is helping us to print that value 5 times. This statement 5 times. What happens? Let's look at this at a closer, closely. So the computer will start here, initialize the value of I to 0, then check the condition. Is I, the current value of 0 of I is 0. Is 0 less than 5? Yes. So it will execute this statement. Then comes back here, increments it, increments the value of I, then comes back to the condition. Is I, now I is 1, less than 5? Yes, 1 is less than 5. Executes this, increments this, repeats this, and that continues all the way until this condition becomes false, and then it has to move outside the for loop. A few more interesting things, like if you said if we wanted to get outside of this before we get to the 5th time, we can try something like if I is 3, if I is 3, break. Let's see what happens. If I is 3, break. So break statement, we've used it before to move out of a function. So it's really useful, you see. We can execute it 3 times, 0, 1, 2, 3 times. But when it gets to the 3rd time, then it has to move out of the for loop because of this break statement. So those are some of the things you might want to know when you are using looping statements. So that's one of the looping statements. We can use it a bit more meaningfully. For example, I want to not just write hello, I can also indicate the position that I am right now. So I represents that position. Of course, we know we use plus to join. So let's look at that. I will be replaced by the actual value of I, which is 0 all the way to 4. So look at that, 0, 1, 2, 3, 4. And of course, when you want to count, you don't want to start from 0. So you can add 1 to this. Let's see whether we can add 1 here. And that will start now from 1 and stop at 5, which is easier for us to understand. We don't count from 0. So this should make more sense to us. Look at that. Hello, 1, 2, 3, 4. So this I, the value of I, is very important. As we go through the loop, it stores the current execution iteration. The next looping statement is while. And while can be used to achieve every other thing that for loop can be used to achieve. So I want to use the same statement to use while to come up with the same output. While, just look at the difference. Now I'll use j, while j is less than 5. Unlike for loop that allowed us to declare I here. For j, we need to look for a place and declare it. It does not give us a place to declare and initialize. Also, for loop allowed us to have a statement that keeps incrementing and allows us to move out of the if statement when this condition becomes false. So, while does not give us that option, we'll need to do it here within the body of the while. So here I'll say j++, and now, so we now have the increment, the declaration of the variable, the condition, and the increment statement, just like what we have here. So all that is left is to have this statement here, and they will be functionally the same. So this is now j. Right, we expect that the output is not any different. So the first part is for up to 5, that is for the for loop, and then 1, 2, 3 again, that is for the while loop. The while loop. Not any different. For all these statements, for both for and while, the program, these statements cannot execute if this condition is false at the first check. So it has to be true for these statements to execute. There's another version of while, we call it do, and look at it. There's a slight difference. We call it do, some people call it do while. So this will first do the work, and then on the next execution, subsequent execution, it will check whether the condition is met. So look at this. Now I'll use k less than 5. So I'll need to declare k here. So it's up to you to use any of this. Okay, let's look at the difference here. Let's first make this condition not true. Can we start where j is 10, see whether this will execute? And even for this, let's make this 10 and see whether they will print hello before we go to the do. It doesn't print because it cannot even go here. 10 is not less than this, and therefore this cannot be executed. 10 is not less than 5, therefore this cannot be executed. So even at the first entry, this is checking the condition. But do while, we can do the job at least once before we start checking the conditions. So look at this. This is now k. K, and we need to take care of the increment statement within the body of the do while. So look at that. Let's run it, see what happens. Let me comment out this statement so that we're able to isolate and focus on the do statement. Okay, you can see it's the same output. It's the same output. Now, let's make this statement false. Let's initialize this to 10, and the condition here says 5. So this becomes false. So essentially, it should not print anything. But because this is do while, look at what will happen. See, it prints it at least once. What happened? Do while first will do the job and then increment the counter, rather the value of k, but all the other subsequent executions, it has to check the condition. And because the condition is now false, it will not execute it again. But the very first time the loop, the iteration went through. So those are the control statements that are commonly used in Java. you can find time to practice on that. As a recap, we looked at if, we looked at if else, we looked at else if ladder, sometimes we call it chained if else. We also looked at the looping statements, we looked at for statement, we looked at while, and then we looked at do. So when you want to use any of, you can use any of this depending on the logic of the program that you want to implement. That's all for this lesson.